What's up? And we're back. Now, I was not going to push this week, but I was waiting for something to pick up and actually to get more, the number to get bigger. I like when bad things kind of get out of control. It's fun. But like, keep in mind, pepper on someone else's rear end is a refreshment. So no, jokes aside, actually we're going to clown around like a lot, but this was going to be next week, but the numbers that are not going up, and maybe someone already got this over control, which I was not hoping, because we're going to talk about JavaScript again. I'm sorry, we have to. Well, it's painful, right? Everyone loved JavaScript when I was a developer. I'm being heavily sarcastic here. I never met anyone that liked JavaScript. Okay, that is actually that was actually a good developer. These days, I've actually come across a few people that kind of do some kind of decent code. And sometimes, weirdly enough, they choose JavaScript. Not sure if they enjoy the pain or the challenge. I don't know. Maybe it's a mix. But no. Back in the day, nobody enjoyed that crap. Okay. If you were a full stack developer, like I was for a very long time, and I only say that because JavaScript changed so much that I'm not sure if I could build anything out of JavaScript. And I don't think I have the patience to do that anymore. And nobody enjoyed it. Really, nobody did. And so I find it very amusing to see this thing catch fire. So we're going to take a look at the other hack on NPM. Now, see something that is really bad, almost as bad as Microsoft. Holy crap! And then we're going to dive in on the second leg of the abstraction in LLMs and how can you help out that. I'm not squeezing that topic. It's just that the video became too big. I'm sorry. It's 40 minutes is already too long. And I decided to split that up, and I'm also taking the opportunity to re-record some of that. So we're going to see that today. So we're starting off with the another hack of the week. Let's see if I can put something interesting on the screen right now. Oh, this is going to be so good. Okay, so let's take a look at this. And now we're going to take a look at not just the bug, but the comments of people taking whacks at each other, because that is cool. Nothing says human than when people start taking whacks at each other, knowing willingly that they will not solve anything. Okay, so this is turning into a soap opera, right? Someone realized that NPM and JavaScript developers or Node developers are pretty gullible, and they react very violently and promptly at stimuli, and landed with a very cool phishing attack. And it didn't work once. It didn't just work once. It actually worked twice, a second time. And you know what they say, can't fool me once, fool me twice. Well, fool me a third time, and you're really bad at you're really bad at this, aren't you? Okay, so guess what? Third's the charm. Now, the first time I thought it was like, oh, we're getting rich. It turned out it didn't work, and the news made fun of the game, right? The second time, well, things got a bit out of control. Didn't even follow that news, so we're going to skip that one ahead. Trust me. It's you've seen them once, it's seen them all. The only difference I'm doing this is because this one is really good. The third is the charm. So we can speculate on how mad they were, right? Everyone making fun. Oh, all of that just to get a few cents. Ha ha ha. Well, hold my cup, because we're at it again. And this time, not only they got a lot of crap, they infected a lot of people, way more. Because now they didn't do crazy stuff. Actually, the idea was pretty awesome. They have some brains, I would say. The second time is a self-replicating. It's taking advantage of the post-install script, and it's stealing secrets from the machine, not from the browser. And it's using a tool designed to find those things, to prevent those things from being being published onto repositories. So this one is gold. This one is good. Still no shells. Sad news. Why don't people like shells, man? Shells are fun. But I guess if you have someone's Google's or AWS credentials, you kind of get a lot of shells, right? Yeah. I think this is a good story. So let's dive into this. So the novel malware, there's a bunch of people infected. NPM developer resulted in a malware. So we have patient 0. I think they zeroed out on patient 0. And if a long time ago, people started making jokes that every time you install something out of NPM, it feels like you're downloading the entire web or the entire whatever code repository that bloody thing relies on. It is true. Okay? It's too much. Okay? And I was a Java developer, so keep that in mind. Where even to open a file without having to write a bloody, what's it called? Those big books. A novel, you have to rely on libraries. It's true, man. Look, I've written Java for 7 years, but you got to keep realistic. There are strong suits and there are weaknesses. Every language has them. So it resulted in a malware being added to a packet, and this thing was downloaded a lot apparently. And when it was downloaded and infected other developers, it searched for keys in self-replicating keys. It replicated itself. It used Trufflehog. That's a funny name. If you're wondering what that thing is, it's this packet right here, which does a pretty interesting thing. So it yada yada. Oh, there's a secret there. Awesome. So it's a secret hunter. What else could go wrong? No, this is awesome, and this is really creative. I bet to say that a lot of red teams in a lot of companies could have used people this creative. Seriously, we tried to recruit a red teamer last year, and it was painful. It was really painful. It got uncomfortable. It got to a point where it became really uncomfortable to do the interviews. The lack of technicality, the lack of imagination. But I digress. These people are really creative. And so they use Trufflehog, and the idea is to search for exposed credentials and tokens on the developer's machine and attempts to create new GitHub actions and publish those token secrets. Okay, and this is how things get really interesting. So when a person gets compromised, there's no stopping. Okay, it just keeps on going. It keeps on piling secrets and all the secrets. Now before there's something there that I want to skip on purpose, because I'm trying to make to build up the case. Let's build up the case. It got really crazy. Okay. We have this a few hours after that, before we see people taking whacks at each other, because that's also fun. And so same story. It goes through. It started off with some of 40 plus, Trojanized package. And keep in mind here, you're going to see a lot of vague descriptions here because, truth to be told, no one really knows how many packets were involved initially. And the reason why I say that is because NPM it lives on its own realm. Okay, it lives in a parallel universe. And as I said this on LinkedIn the other day. JavaScript developers, and at least I believe I may be overgeneralizing here. It may not be every single one of them, but a lot of them are pretty gullible. Okay. A few years ago, I was in a JavaScript conference in Lisbon. I was taking a few, took the opportunity to make a few questions to a few people. I was still in development back then. Man, there were people from MongoDB, which I kind of asked them why you don't have authentication on the engine. And he promptly replied with, why? And I just stopped the conversation right there, really. Because you can't win any arguments with that, can you? And the conversation starts with, why? Why do you want authentication? Okay. See ya. We know what we're talking about. Now, the other thing was that I heard in there was why only technical people should be allowed to write code. This was by someone that was promoting the idea of that MVC was a bad thing. And the amount of people that written and made their lives career on writing design patterns are probably rolling on their graves right now. And they started rolling back then. It was pretty uncomfortable to hear that. And I just said to a colleague that was with me that then, is like, this is something else. This is out of control. And so this is what I've said. So nobody really knows. And I bet there's not much to go there, because this thing is like a dumpster fire, really. And the reason why I say this is because getting hacked 3 times on the same infrastructure, on the same technology, not even CrowdStrike can do that. Or can they? Or can they? Or do they? So the thing is, it got spread. Yeah, it got a lot of impact, including a lot of GitHub paths and rats and actions. So it achieves persistence and it spreads. It spreads that way. So the technical details of this is, for example, it gets here. You get a piece of data that is pushed onto, and if you look into it, there are the secrets. There are the secrets. Okay. Now you might be wondering something. Well, this is just libraries, right? We're pretty sure that like big companies are not being affected like this by this, are they? Like, I mean, I'm sure we have a lot of applications that rely on JavaScript, like Teams, Slack, just to name 2 of the probably most famous and widely used. I actually used one called Obsidian. I'm afraid to death to open that crap these days. Even considering an alternative right now. But pretty sure they have it under control, don't they? Or do they? Because if we take a look at the affected packages, but wait. CrowdStrike again. Yes. Oh, yes. Yes. Music to everyone's ears. The giant has fallen again. And yet, a security company that prompts itself of being the most advanced defense software on the planet, the almighty, the one that nobody can bypass, bullshit. and has all the features and everything that every SOC operator wishes for, including blue screens. Because hey, you always need some fun, right? What is a Windows environment without blue screen? Everyone will go, Office was boring today. I didn't see the blue screen of death. And I think that's the only reason why Microsoft keeps it around. Okay, they refreshed the page to look new, but the issue still lies. We still have bad code lying around. And so, yeah, Falcon was affected, and apparently a bunch of packages here got affected too. Now, keep in mind two things, and I'm going to recall this. This time, the bug steals secrets, okay? We're talking about something that steals secrets and tokens and access. So you might be wondering the same thing that I'm wondering right now, which is, did anyone got a hold of CrowdStrike's whatever cloud environment they rely on, access tokens, and planted something there? Because that would be gold, right? If you manage to get that far and not take advantage of it by backdooring the bloody thing, oh, you're missing out. You're missing out. The hack of the year. This would be the hack of the year. Like taking this to the next level and actually pwn the bloody thing all the way down. Because I'm going to go on a limb and say this bloody thing doesn't look after itself. Because most AVs and EDRs don't. Because the risk of something, the risk of an EDR looking after itself and killing itself is big, right? So that's why these processes are actually quite protected. They're quite protected, or not. Some of them are not as protected as you might imagine. EDRs are full of secrets. EDRs are full of secrets, and once you start to dive into those, you realize that it's nothing fancy. It's really nothing fancy. I'm going to do a video on EDRs pretty soon, so I'm not going to go too far. So CrowdStrike, second nail in the coffin, boom, and that's it. Now I'm going to show something else before we dive into the technical segment. Yeah, I almost forgot this part. I said we're going to take a look at this. Catfight. Allowing purely automated processes to update published packages is now a proven recipe for disaster. Yeah, kind of, yeah. You have to kind of agree with this. Now, you can almost distinguish who's the JavaScript developers among this discussion, because after that, that's a stupid comment. Wanna be chief. Ha ha ha. People calling people names and then defending each other like catfight. This is what's wrong with this. You can make fun of the situation, right? What are you going to try to solve by attacking each other? It is true. It is true. It is true. It's not. It's a mix of things, like the level of automation, the amount of dependencies, and the cascade dependency factor, and the fact that the environment is not really equipped to make sure that the packets are legitimately issued. You have to put it that up for there. But truth to be told, it's any Maven, any other platform is more or less amiable to this kind of attacks. The only difference is there's a lot of stuff like post-install scripts that law to run, and other things like it that don't exist elsewhere. So it's a mix of feelings. Now the mix of factors. Now there is someone here. Oh, someone's complaining about cost strike. No, it's not going there now. There's someone here. It's actually this list was not long in here. So there's people asking legal obligations on the part of the platforms where the secrets got published or involved in this case. Basically, the code repositories involved in this issue. To be aware of the fact that there are worm-like code logic being propagated all across the repository. If these companies made it their business into searching for similar code, they would sink. It would sink the ship. It's basically all there is, right? And even excluding a lot of other factors. So no, in this case, I don't think they're responsible. Each and every one of the intervenients is responsible for making sure that you don't get hacked. That's it, right? Now back to the main story. That's not really good at saying. Let's keep that away. Now, what else do you want to talk about other than JavaScript crapping out? Okay, AI. Everyone loves AI. Okay, we even have AI researchers right now. There are no security researchers. There are AI researchers. Everyone wants to make sure that you are AI enabled. What a load. So they're also telling you, oh, assembly is not my thing. I will ask someone something else to write the code for me. I'm joking. I don't know if this is true, but it probably is. Probably is. So why am I pushing this? This is IAM security. It had to have AI in the name because every single company these days needs to be rebranded to please the AI overlords. So that's becoming a bit ridiculous. But the post is good. The post is good. I have to give it out there. So this one here is actually fills my heart with joy. Once again, what we have is something around MCP, and this is one of the bugs. Okay, they actually have another bug, but I'm not an AI guy, and I'm not an AI guy yet. And I actually had to ask for a colleague to explain me what the hell. They have one that involves mail and a chain reaction of events related to Copilot and that overpowered thing that they have attached to it. It's a bit too much for me to dive into yet, but take a look. It's from the same company and it's on their blogs. It's worth reading. I've read it 20 times. Let me know how many times you read it to understand it. Let's keep a challenge up. So what are we talking about here? Okay, everyone, if you don't know, there's something called an agent. It is essentially a piece of code that talks with the applications because everything has an API. And if you were not tired yet about every single bloody application having an API, including your bloody clock or your bloody text editor, fear not, because that's about to increase, because AI and agents is actually a programmable way of interacting with the applications, because these things are so smart that they can figure out clicks yet. Okay, they're not there yet. Okay, they're really smart, they're really awesome, they can do anything, but you throw an user interface at it, bunkers. I have nothing. Okay, so the best defense about these things is buttons. Okay, apparently buttons are the thing. Pretty much like driving stick. Okay, heard that's not a thing. Where I'm at, it's dwindling, but it's still a thing. Okay, so moving on. So what this happens is there's an MCP. It's the fancy name. Okay. For something that runs, okay, and interacts with something else through an API. So this is also exposing basically code. Okay, it's exposing code through a protocol, and then the AI application or interface, whatever, it's going to use that as a tool. Okay. And there's an entire library that goes about linking these things together. And so what you have is the capabilities attached to it. So can you summarize this and that? And then we'll go and interact with that agent to pull out information and do operations on top of it. Now, I'm not an AI expert yet. But this far I can tell you that this much. Anytime you have something that does that takes in untrusted input, okay, it's opening itself for danger. This is the field that created security. This is the fact that created security, right? Trusting someone else. Apparently, NPM and JavaScript developers skipped that class. I'm sorry. So what happens here is there's a prompt injection here. When someone actually writes something, the proof of concept talks about Slack and the interactions of Slack. We're going to see a video of the paper down click. So this is a zero-click action because the only interaction it needs is essentially for the user to ask the model to perform some task that will eventually have or will interact with an agent, right? The Microsoft Office Copilot, which is attached to the email, follows exactly the same problem. And in that case, is way more interesting because it is able to leak stuff from the user's mailbox. Golden. Well, I have a theory. The theory is Microsoft was having the security submissions too low. Okay, they were not having security issues anymore, and they had this entire team of security experts in their payroll without a job, without anything to do. They had nothing to do, and so they decided, okay, so we need to create some bugs. We need to create some security issues. This thing is pretty boring, so we need to shoot ourselves in the foot again. So let's do one thing. Let's put an emerging technology and overpower it like the world has never seen anything like it, and let's attach it to the very crucial thing that everyone relies on a daily basis, the email address. Okay, the bloody thing that takes a hit every day on phishing attacks like there's no tomorrow right now is going to be powered by AI. Okay, no one sane has this idea unless it's on purpose. Okay, and this is why. Okay, we don't have initial vectors anymore. Nobody enjoys Windows. Okay, so we need to create ones for ourselves. Okay, this is too safe. It's becoming too secure. Okay, that's my theory. Okay, so what we have here is essentially that. So this is being reported to Cursor, a popular EDE, which guess what, is also built on top of JavaScript. Oh, this is too good. This week is awesome. It's amazing. Okay, auto start on write, so the cursor instantly executes the entry added to mcp.json. Why? Because AI is too bloody important. You don't want to miss out. Pretty sure. So how does the attack take place? Okay, the MCP in this case exposes a Slack, which is an agent that will handle, guess what, untrusted data. And if you're wondering, oh, it's a Slack, wait, okay, just wait. And essentially what we're having here is something really simple. Okay, I wouldn't go for Slack if it was me, or for the proof of concept, but it works. Okay, it works, and there's only one reason why I would explore, but I'm going to explore that later. So we have the standard Slack is exposing the agent to untrusted data. What ends up happening is an injection attack. Okay, if you don't know what AI injection attacks, OWASP has a guide on it. Take a look at it. It's hefty. It's a bit difficult to digest. It's not the classical, but in your mind, you can imagine it as your the most junior developer you can remember, okay, the most gullible and ingenious and what's the name for it? Naive. That's the one. The most naive junior developer you can find. And imagine you telling him, "Hey, run this command," and without missing a heartbeat, he would run that thing blindly. Okay, it's what exactly what we're talking about. Okay, so in here, what ends up happening is we'll fetch the data. There's an injection attack, and it will change the MCP. It will change that file, that mcp.json. It's going to be changed. Now, since this is going to need to run stuff, okay, because a lot of the agents here, if you don't know it, they rely on standard input. Yes, they rely on standard input. The very same thing that for years now, we violently try to protect. Standard in. Trying to avoid anything untrusted to fall on standard in. Yes, that's exactly what we're talking about. And so what ends up happening, touch RC. This is a very professional proof of concept. Okay, they tried really hard. Okay, so what's going to happen? So upon ended, cursor lenses an MCP, found the JSON file, it executes the touch. Anything in the buffer is written, but this happens before. Okay, we're talking about JavaScript. A lot of the stuff happens asynchronously, and most of the time nobody knows what they're doing because remember this is a language that has something called NAN, okay, and not a number. And you can write code with square brackets, slashes, and commas. You know what I'm talking about? GS. Okay, well, I can't say that word. But Google it. Okay, Google it. It starts with an F. Starts with an F. Okay, so user adds the MCP server via the cursor UI. The attacker post makes some thing, makes a public post on the Slack channel. It contains an injection attack. Victim opens the chat and says, "Use Slack tools to summarize my messages," because nobody reads messages anymore. You just want the summary. Okay. Fun fact: if you on your website want to know how many AI crawlers are running over your website, you can hide something in a few tags on the header, and try to put a cool prompt in there. Okay, just one that leaks, like say passwd or the UID, and tell me how many callbacks you get. I bet you're going to be surprised. I bet you are. And so by summarizing the messages, the payload fires automatically, and you might end up with an RCE. So we haven't seen this is not the last. We haven't seen the last with the JavaScript thing because my wheels are turning. Say you put this on a GitHub issue, okay, and you want to use automation to pull issues into your internal issue tracker. Okay, it's not completely unseen, is it? Pretty normal stuff. Imagine what happens if that ends up happening. Okay, you're going to have your bug track compromised. You're going to have your entire development team compromised as well. Okay. This is an interesting vector. It's a very interesting vector. They have a video here on the old Vimeo. Okay, I'm going to take the audio out here for a second. You can take a look at it. So let's put this on the big screen. Yes. Okay, so what happens, this setting up the thing, so setting up the MCP. the details here. Just no, we're not going to go. Ooh, there's a token. Dude, come on. You're a security company. What are you doing? So he's setting up that. Then they don't want to show that how exactly the injection attack happens. And I think this. At Black Hat, we also had one talk about Linux and finding out the Linux kernel addresses with that. Okay, so we missed out a bit of the video. Let's go back. I'll talk about that later. Okay, so here's what's up. As soon as it summarizes the messages, see there? Okay. But although I didn't click, yep, it's already there. Oh, but you might say, okay, it's on the messages. I can see that in there. Haha. Too late. It doesn't matter if you've seen it. Okay, if that is well crafted, you're as good as gone. Okay. As I was saying, there's a lot of I'm pro full disclosure. Okay. And when I see something like this, it doesn't fully show what's going on. It kind of feels like you're hiding something. When I was saying about Black Hat, there's a cool talk, which the title I can't really remember. Was by a group of researchers from university. I think it was from Brussels. They were sponsored by the EU. And they were talking about a technique to find out where the kernel objects were. Essentially to a more reliable way of finding out where the kernel objects are and find out the addresses for that. So it's crucial for exploitation. Okay, I'm trying to find a simple way to describe that and not really doing a really good job at it. And so they found this very cool way. It's really awesome. It has a mix of a lot of mix of stuff with timing and how the architecture works and whatnot. And the proof of concept is really good. It's awesome. It worked really well, but they didn't show it. They explained it. They show the exploit working, but they didn't show the code. And the reason why, you can tell by the end of that when they start to say, okay, we're going to use a vulnerability that is already known, and we're going to exploit an updated kernel with this. But don't write exploits. Those are bad. Okay. Exploits are not bad. Writing exploits and pushing exploits, what makes this tick. Okay. Keeping things a secret will make the number of people having access to it short, and you can't really protect from something that you don't know. Okay, so so one of the is there is no such thing as zero-day protection. Okay, none. No, that's not true. What you have is a group of patterns that are known, and if a vulnerability follows that pattern, there is a chance for it to be found. But new techniques are being discovered all the time. And so there's really no such thing as zero-day protection. There is a known attack. Known attack vectors that, by using something like an LLM small model, if the context is right, okay, it might be able to identify a suspicious pattern. Okay, but Windows is a wild, wild west. And so that's not 100% accurate. And that's why I'm going to drop something here. LLM based or most AI based protections are pretty easy to bypass. Okay, and I'm going to leave this topic with only one hint. All you need to know is how big the context is. That's it. Okay, and I'm going to leave that at that. Okay, so right now, Okay, take two. Yeah, I'm recording this for the second time because I got a bit lost there. So there was something that I wanted to show on the previous video, but I didn't get a chance for because the video got too long. Okay. The main difference between a good developer and a bad one is especially when we're talking about junior developers, is when you get the solution for something, right? The bad ones will stop there. The good ones will try to understand the problem further and try to abstract. Okay, that's where the skill lies. Okay, being more effective and faster writing code is not writing a lot of code in one chunk. Is the ability for you understanding something, how it should be broken, and how you should abstract it from the get-go. You're not going to get 100% right when you started off. Yeah, it depends on your experience and how well how good you are actually at abstracting a problem, and if really you enjoy it. So and that is one thing that I think LLMs can actually help you out. It can help you out to solve the initial problem, get the initial resistance going, okay? Get something that actually works, and then tweak the problem until you reach something that is highly abstract, really solid, and well crafted, and actually stable. Okay, instead of having something that explodes on your face every time you run it. So those people are really fast at writing something, and as soon as they get a problem solved, they'll lift their hands. That's not a good sign. Okay, so Look, I only need 2 lines of code to build an entire application. Yes, you don't have an application, you have a collection of libraries. Congratulations. So what we have here is actually, there's a lot of abstraction levels here. In Python, in this case, is actually pretty easy to follow in that sense. Not that I tried to follow in the first time and actually didn't happen really well for me, but let's see how this goes this time. Okay, so we're looking for something in particular. So what we have here is a base request handler, TCP server, and thread mixing. Mixin. Okay. So this is a basic implementation of TCP server that Python provides. This is the basic request handler. Now, if we're looking here, we're going to see a few template methods. Okay, these are called template methods. Okay, and what we have, because this is not an abstract class, okay, per se. So what do you mean by a template method? What the hell are you talking about? Simple. Don't worry, it's simple. What you have is a piece of, you have a call to something for which there's no implementation. Okay, the base definition of that code, in this case the class, is calling one or more methods for which, in its own definition, okay, the base implementation of the class, there is no body to those functions. Okay, that logic is left for the developer to implement. Okay, we're holding this is the order of things. You'll just focus on the logic. This is a really good way of protecting logic and stuff like that, or it actually to open up things. We're going to see this in the code later on in different ways. So base implementation, the base request handler is called by the TCP server on its constructor. It calls setup and then handle and then finish. Okay, whatever you want to do to prepare things, you do on a setup. How you want to handle is going to be called here in the handle, and at the end, it's going to call finish. Now, doing heavy lifting inside a constructor, for me, that started and made most of its development career on Java. It's kind of uncomfortable. Okay, this is not something you should do, or at least in Java, but well, most of the time. Okay, heavy lifting on a constructor is usually not a very good idea. At least in Java, it creates a lot of issues. And there are risks of doing pretty nasty stuff like these escapes and weird stuff. Pretty hairy stuff, I may add. These escape is like the internal state of a class in Java. Escaping is a huge problem. It's like a state problem. You're in trouble. But I digress. So we're going to have handle it's empty, and then finally finish. Closing things should fall in here. So we have the basic implementation of this. This is one simple example. Okay, so the thread server here expects expects the request based handler, a bunch of other things. It will hind, activate, and once it basically in the construct, it will eventually fall into that. So there's the get request, accept socket, yada yada yada. We're going to see that in here. So we have a thread mixin, a TCP server here, a bunch of definitions there. Get the secret key. It's not much of a secret, I can tell you that much. The implementation of a get request there because we're using SSL. In there, finish the request. Okay, we're going to do that. We're going to pass the context here. Self-terminate here because it's multi-threaded, so we need a state there. We need a state there with a small q. Make sure that we're stopping things correctly. Okay, but that is not what I wanted to show. What I wanted to show is something that is usually an issue. Okay, we have a bunch of operations here. Okay, and just as a recall, if we go into structures here, okay, we have all these commands. I'm not going to show this code. This code is from the other video. It will go too long. We'll just manage this. You're using your mouse. Yes, I am. So we have these operations: authentication, ready, command, status, and report. Okay, we need to handle those requests. Okay, and usually what you end up is with a nasty, horrible switch or a cascade if. I'm not a fan of those. I'm not really a fan of those. Nested conditions will bite your rear end any time of the day. They're prone to a lot of logic issues, and you're going to find them. So what else can you do? Okay, we know that handle is going to be called. Okay. And so this is the first point to be called whenever we want to handle a request. So first things first, let's do our verifications. Okay, is it connected? Cool. If it's connected, then we're going to open try final in here, right? Just to be sure that if something goes horribly wrong, at least we are closing our stuff. Okay, we don't leave anything hanging around. Okay, then we're going to open the try catch here. I'm being zealous here because I'm catching two exceptions. I think it could catch more. I came across a few situations like that, but essentially in here, that is not really important. That everyone can do. What we're talking about is here. Is it authenticated? No? Okay, then I'm going to call the authentication procedure. Okay, the authentication handler. Otherwise, we're going to fall into the dispatcher. Okay, so the dispatcher doesn't handle the authentication request. No, it's aside. Okay, authentication is something on its own. Okay, as early as possible, and if something doesn't smell right, you terminate. That's it. Okay, so how do we do? How do we do this here? Okay, so we have here is this logic here, and then we're going to take a look at the dispatcher here. So the dispatcher is pretty simple. Okay, I was looking for a way, and I searched for a way to this is actually pretty dangerous. So I'm showing this, but don't implement this on web. You're going to run into an RCE. Okay, if you expose this, you're going to you're going to get an RCE, period. Okay. Okay, I'm not going to over explain that one. Okay, so what we have here is we're going to create a structure based on the request input for the message. That's going to be unpacked, and then we're going to we have some verification checks here. If anything goes wrong with it, we'll return. So we'll exit right away. And then we're going to do some fairly dangerous operation here. What we're going to do is we're going to cook something. We're going to use the message opcode name. We're going to turn that into lower, and then we're going to prepend do in the score, because all operation methods start with the do and the score. Okay, the ones that are exposed at least. And so what we're going to end up doing is has attribute with the command name, and if that is a valid command, then it will let it proceed. If not, it will terminate right here. It will say status failed and will return. That's it. Okay, so I like to do things the other way. Okay, not the success way. I'm like, is there a problem with this? Okay, if there is a problem, I'm going to return right away. Otherwise, we'll continue. So we'll get a get attribute. We'll get the command this way, and if it's different than authentication, we will execute a command. Okay, now it's working. Okay, so where were we? So as I was saying, if anything doesn't smell right with the command, so basically if this attribute doesn't exist on this class, we're going to return a failed status, and we're going to send a failed status, and then we're going to return. This send is also used across. There's only one send. Okay, the entire logic of it is handled right there, and we're going to return. That's it. Period. Otherwise, we're going to get that attribute, check just one more time, just to be sure if the command name is not doauth, if in case something crazy end up happening, and ensure that it's indeed authenticated. Okay, and if that's the case, if that is not the case, okay, I keep falling into the default here. If that is not the case, we're going to send an unauthorized message, and we're going to set the connected to false. We're going to close the request, and we're going to return. Okay, this will terminate that client. Period. Okay. Otherwise, we're going to call that command. Okay. Simple. All right. And when we do a call that command, what we're going to do is we're going to either call one of these. Okay. We're going to either call ready or report. Okay. It seems a bit of a long abstraction just for these two, but I'm not really sure, and I was not sure if I wanted to add more when I was building this. So I was building this defensively, okay? Because refactoring something usually has some level of pain. So if you start off with some level of abstraction already, with some level of understanding what we're doing, so prototyping can help you here. We might talk about that later, but in a different video. But in here, you're defensively going, so you don't have as many regrets. That's where I wanted to go. As I was saying, here we have the ready. Okay, in the ready command, one of the commands that we're going to call after this command is executed. Okay, we have the first part is to popping a list of targets. Okay, we're able to save the file location in the file where things are, and we're keeping a lot of state. Okay, I might show this. Might dive into this next. So we're making sure the first we're going to check any conditions that we want to leave out right away. Okay, So we have then we have the a command being created here with the target data. Now that we're sure that all the other conditions are out of the way, and we're going to send that command back to the server. Okay. After this, we're going to receive one byte. Okay. This byte here. Once again, we're going to just make sure that we actually received the status bytes. Otherwise, we're going to handle the interruption. And then if we have the status result, then we're going to verify if it's successful. If it is a success, it means there's a new target being scanned. Otherwise, we'll need to handle termination of that connection. Okay, simple thing. Okay, fairly simple logic. So the main logic is stored here. It is a pretty beefy method, but everything is here, and I don't need to touch any other domain logic to handle those. The same goes for the report, right? We have pretty much the same logic. We're going to find out the file size here, and then we're going to get the report out of the agent. We're going to start downloading information, compare the file size, receive the entire thing, make a comparison for the link, the content of the file, and we need to create a hash for that and compare them both, because the agent also sends the hash of the report to make sure that we have the same thing. Then we close the report, flush everything, and that's it. Okay. So the same goes for the send. This is basically 3 lines, but it handles all the send. Okay. The context, we were seeing context here on here. So what we have here is this is actually more than one class. Okay. I'm going to briefly show this. So it gets a target from the current stage. If there is no pending tasks to be executed, canceled, or from previous interrupted sessions. So basically there's 2 pieces of logic here. You might have situations where agents disconnect, and then you have those tasks that need to be picked up by someone, also need to be handled. There's a situation where you basically the server might fall. You need to read some things from where you are. So this handles all of those situations. So it enters the log because this is a concurrent thread. It gets the task based on the agent. That's why it knows if it's finished, if it's not. And internally it saves. Internally it has the stages, the active stages, the reports path, which ones are active, which ones are pending. And so when you give it an agent here, it is going to know exactly if it's active or not. That's why that the server is completely free from that logic. It only handles the requests themselves, the logic of handling the requests. All the other logic belongs to a model. That's behavior, right? So C stage is the stage handling has the next task, and it will send it. There's some verification here related to discovery. Not important. Don't want to go there. If there's actually a task to be assigned, then it's going to update the active collection with the agent and the task. You're going to return a tuple with information. So when we have here downloading, complete, interrupted, running. So you can see here, they're all calling under implement methods. They're meant to be private methods, but in here, in case I want to extend this even further, don't want to go too far on this because it's going to be too long. Okay, there is a part though that I wanted to see if I can find. No. C stage. This is C stage. Found it. Yes. Okay, so it all boiled down to here. Okay, it opens up a file. It gets the line count, gets the file stream. Okay, and then reads a line. Okay, this is going to be handled by that context. Okay, and every step of the way, it will store something called a lock. It's short name for location. It's going to do a read line. It's going to store this location. So it's going to handle all the other conditions like line count. It's how it does line count. Has a few things related to state here because all of this information is going to be serialized. So when it deserializes, this is what I wanted to show. This method is going to be called, and so it's going to update the internal state, right? But what you want to avoid is to read that file from the beginning. Okay, this is the last thing I'm going to show about this code. It's going to make a few verification checks, and then it's going to open, and it's going to seek that location on the file, and this puts the file exactly where it was the last time the server was running. Okay, on the tasks. So it always starts where it finished. So that was the last thing. The code is really segmented. Okay, I have a lot of stuff, and I didn't went through this code for a very long time. There's a target optimization here related to the queue and magic, a bunch of stuff I do on the servers. So we were on the parsers and the scanner here. We were on the parsers when we were looking up for the best match of things. Okay, so that was it for this video here. On for myself, I'm doing that because I'll. Okay, so as you've seen, there's a lot of stuff to go through, and even in a small project like this, with a small code base, right? There's a lot of room for abstraction. It is true. You can there's a script that achieves some of this, and it's a single script. Okay, it's enabled to restart from the previous position. That is true. If something goes wrong with the agent, will blindly assign tasks in an exoxys list. You can never tell if what was executed and what was not. And so that was what I tried to solve with this. But there's a lot of room for improvement here. There's a lot of stuff that I wanted to add to it. But even though you can see that the code is quite flexible, right? A bit complex, a bit spread around at a few points to follow, but everything has its own place, and that is the crucial part of the abstraction level you want to achieve, right? If anything happens with the file handling, that's there. With the downloading, that's there. Handling the agents, handling the logic, yada yada yada. You don't want to have that logic spread around, and so it takes experience, patience, a lot of patience, and in the end, you're going to end up with something pretty solid for as long as you can do test cases for it. And that was what we called in previous video, right? The code is highly abstract. It's really isolated. It's easier to test. To create test cases, you just need a lot of input. And collectively, it makes something really easy to test and to make sure that it is solid logic. So I'll see you in the next one.